All right, I'm going to try to clear up a sticking point that some kids have with solving equations. I think a lot of young people decide that it's hard to know where to start. So I want to prove to you that it sort of doesn't matter. It's up to you. So right here I have an equation, kind of a long one, 2x plus 7 equals 5x minus 14. And I've decided to subtract 2x from both sides. What's going to happen when I do that is this variable term just completely vanished from this side of the equation. So the only thing that's left here is the 7. So I subtracted 2x from this side also, maintaining balance, of course, and I wind up with 3x minus 14. So keep in mind, my first step, I decided to get rid of this term when I solved this equation. Now I've got a two-step equation left, and I'm going to add 14 next to both sides of the equation, always doing the same thing to both sides of the equation. That'll leave me with 21 equals 3x. And I think you can probably tell that's got to be a 7 because 3 times 7 would give me 21. But of course I should show that I'm dividing by 3 on both sides of the equation. And I'll get 7 equals x. So let's remember what we did. We subtracted the 2x first, and we wound up with 7 for our answer. Now let's look at something else. Another kid might decide, well, I want to eliminate this 7 first. That looks like what I've always done with equations like this, so I'm going to get rid of that 7 first. But what I'm going to try to prove here is that it just doesn't matter what you do first. So this kid subtracts 7 from both sides. The 2x is left. This 7 is gone from this side of the equal sign. Over here we have 5x and then negative 21, so our equation reads this. Now we take our next step and subtract 5x from both sides. Got to get that variable to the other side of the equation, leave the constant on the right in this case. And our new equation says negative 3x equals negative 21. We want to isolate this variable, so divide by negative 3 on both sides. And we got the exact same answer. That's really important to know. So the first kid decided to get rid of the 2x first. The second kid decided to get rid of the 7 first. And they both arrived at the same answer. Now, yet again, another kid might decide, I want this 5x out of here. I'd like to have the x term on the left side of the equation, so they might decide to get rid of the 5x first. And another kid might decide to get rid of 14 first. In this case, I've set up the boxes here. You could choose. Now, I like to get rid of the x term or the variable term from one side of the equation as soon as I can. I don't have any like terms here. I don't have any like terms here. So my first step is to move one of the 4 terms in the equation. And you really literally could get rid of the 6 or the negative 6, get rid of this 10, get rid of the 7x, or get rid of the 3x. This teacher here is telling us to subtract 3x from both sides. And we're going to wind up with negative 6 equals 4x plus 10. We can go from there. But I think the point that I really, really want you to know is that you get to decide. Now, most teachers will tell you the best choice when there's no like terms on either side of the equation, none on the left, none on the right. So now it's definitely time to move something from one side to the other. Your best course of action is to find the smaller coefficient on the variable term. 3x, or 3 is smaller than 7. So the best would be to get rid of that 3, but again, either way you're going to get the same exact answer as long as you maintain balance and do the same exact thing to both sides of the equation. I could literally, and this is sort of off topic, but I could literally add 38 to both sides of the equation and then divide both sides of the equation by 9. But I would just be making more work for myself. So I say get rid of this 3x first, but that's up to you. I hope you're understanding.